Hello. I really hope everyone can see me and hear me. Is everything fine? Can I just get a confirmation? Great. So I just start. Yep. So hello everyone. I'm Noah. I'm a lead smart contract coder at Hacken, one of the top blockchain security firms. And today I'll be telling you about test-driven development in your smart contracts and projects. But in the meanwhile, it's sort of mutated in this broader topic of securing your web project in general because of demands that I've seen when holding the presentation previously. So this is going to be more of a how to secure your project the right way, where a lot of it is actually based around test-driven development. So let's start. Like, what even is a good strategy? How do you approach blockchain development? So for a start, you want to give security priority over other aspects because you're dealing with finances, you're dealing with serious and often immutable things. And you're going to be sacrificing ease of use for security by implementing multi-sigs and other things. Then you want to have proactive and ongoing security controls. That would mean time locks, breakpoints, etc., and pre-deployment, post-deployment measures to keep it secure through life cycle. That would mean separating your deployment keys from your admin keys, multi-sigs again, and etc. This is what we would call a complex approach, and this is what's key to building a good and secure blockchain project. In this complex approach, you're going to be relying on some security practices. So what would be the best practices? For a start, you want to know what you are building. You want to have functional and technical requirements. These are key to success. Next, the test-driven development part is to validate what you built is to spec. Test-driven development makes sure that what you're building is what you actually intended to build. Then, while you're building, you want to make sure everything is flowing real nicely, and that would be continuous integration with linters, tests, code formatting, whatever you want there. Fourth, other than the continuous and automatic stuff, you want to regularly review and analyze your code using tools such as Slither, Mythics, and recently Smartbugs. In general, you want to have security in mind. You want to educate yourself on blockchain-specific exploits because those could be to the detriment of your project. And once you feel you're ready, you want some actual, some professionals to have another look at this. So once you have code freeze, undergo an audit with a reputable company, of course. So let's go over each of these points real quick. Requirements. So for requirements, it's really important that everyone really knows what you're building. By having specification, so NatSpec, user stories, tokenomics, invariants, everything that really defines your project, you can make sure that nothing is being improvised on the spot, which is very important when you're building something with finances. Especially want to be aware of your assumptions about user counts, about limits on something, about access, especially. Those are really big. Next, once you have an idea of what you're building, you want to take a critical look at it. You want to model threats. You want to identify risks, risky roles, and your controls within the projects. For example, your admin accounts could be compromised, and like half of all hacks are still due to key leaks and similar things that could be avoided by simply using a multi-sig, or even having better role-based access. And finally, treat yourself like a king or a queen. So you want to have user documentation. You want to make sure you have good tutorials, run scripts, installation docs, FAQ, everything that you may want when you're looking at this code and you're not really feeling great, you're a bit tired, or because you want your users to have a very clear idea of what you're building as well. So that's where we get some usability. Okay, this may seem like a bit much. So what if you want to just do everything without requirements? Well, it's going to be a bit of a Wild West approach. You're going to have a very flexible product. Developers are probably going to improvise a lot in terms of solutions, and you will probably not be aware of future complexity. You may not be aware of stuff that may go wrong in the future. Other than that, there's no real benefits. Like, you may feel that it's okay that the founder has everything in their head, but the founder keeps explaining stuff to the developers slightly differently each time, and you get a sort of messy project. So instead, you want to have well-prepared requirements, because then everyone knows what you're building. You're never surprised about any outcome. Like, everything is going to feel planned and like a proper process. Even if something goes wrong, you know that it went wrong in development, but then the QA found it and checked it, etc. You're going to cut development expenses because you're not going to be paying extra hours to fix stuff that should have been right the first time, and you're not going to be getting lost so much. So you're not going to have as much double work, re-implementing features, not being sure how stuff is supposed to work, etc. You're going to be able to plan better, because once you have an idea of what you're building, you can get better estimates. And when you get to the audit, it's going to be perfect, because we are going to be very happy to see code with proper requirements that makes it really easy for us to audit it. I mean, sometimes we get clients that are, angry because we didn't catch a formula that was wrong, but they provided no reference documents for what that formula should be. So it was purely based on our intuition about the formula, whether we catch it or not. Well, if you provide documentation, are you going to write it incorrectly in 3 different places? It's harder to make such a big mistake. So to go over the main rules, you want to prepare high-level requirements. What is your project? Is it a DEX? Is it an ERC-721? Is it whatever? And write those down. Then you want to decompose those into different elements and write those down, so you have a layered specification. As you're getting more and more detailed, you'll get to some calculations and some math. So describe each formula and write down what each function is supposed to do. This is where the NAT spec gets very, very useful. This is more of a technical specification at that point. Now that you have like a general functioning thing, you want to make sure that it's actually usable under load. So you want to have an idea of your audience, how many users you're going to have, and you want to make sure that it checks out. If you have something that, like, you can have denial of service issues because you have unbound arrays and too many users that you cannot process and stuff like that. So it's important to know your loads and prepare technical specs of your system. Finally, keep talking to your technical team. So you want to talk about all the edge cases with many or few users, and you want to make sure, talking with your technical team, that your requirements are always following your changing business needs. Okay, this may have seemed a bit abstract till now, but I feel it's very important to set up some baselines. I'm not sure if you're familiar with C. Michel from Code Arena, but for a period of time, there's been some memes, about the stuff he says that sounds a bit iconic. And one particular sentence that resonated with me is, every hack is due to an error in either business logic or its implementation. So yes, it's about security, because it's way harder to get lost when you know what you're building. And if your business logic checks out, if your business logic is secure, then your project is going to be secure as long as you implement it correctly. So it's important to know exactly what you're building, because then you can catch all sorts of issues. And finally, test-driven development. So some of you may not be familiar with it. Some of you may not be familiar with writing tests. But in general, you do not want to trust your code. Have you ever opened a Google Doc or sorry, a Word document and read it a bit and then closed it and realized, I accidentally saved something. I maybe, I was reading through stuff and I clicked on something, you messed something up. Well, tests are security. Other than Git, which provides you a good difference, tests are a security that when you were implementing a new feature or optimizing a function, you didn't break any functionality. So you want to, and this will only work, of course, if you have high coverage by tests, if every possible interaction is covered with tests. This may seem like a lot, but it's actually not that hard to implement. So test-driven development works this way. You read your requirements, you write tests with usually no code present, only maybe an interface. Then you write code, functionality to make the tests pass, and now that you know that your code is working, you can start optimizing it, changing it, and while it's changing the code and knowing that the changes still work. Of course, you want to have high coverage, and you want to have negative tests as well here. So there's this thing called happy path testing. That would mean that you only tested, the user came and clicked the button and nothing bad happened. But you want to also check that the user came and injected an SQL script or something, in traditional security, and nothing broke, or that the revert states are reached properly. So you want to do the rough path testing. And I know to some of you this may seem boring, but boring is amazing. Because when my job is really exciting, it's when someone gets hacked, when there's like $1 million on the loose, and you got to figure out using on-chain analysis who did it and how exactly. And then we're really excited, at 1 a.m. looking at the hack and racing to get the analysis before the other companies. And that's all really exciting. And at the end of the day, we're really glad it was not one of our projects that got hacked. So security is exciting when hacks happen, and the best security guys go unnoticed because there's never any trouble for you to notice them. And test-driven development, it enforces creation and compliance with requirements, better code quality and design, and it provides you faster development and cheaper maintenance. So it makes everything a bit boring, but also makes it work great. Okay, say you've written a really, really good project, and you feel it's secure, you got some test coverage, right? Well, if you want to go more public with it, if you want to put your code out there on public GitHub and have all of your community read it, you want to make sure it's presentable. For this, we get to the continuous integration step. So we want to use linters and formatters, security analysis tools, and automated workflows in your repository for integrating your code. Not just because it looks professional, but because it also makes it easier for you. You're not gonna have any weird formatting issues. It's just gonna make everything consistent no matter what machine you're coding on and from where you're committing. And on the flip side, you may be wondering, okay, but we could do this, but I mean, aren't we paying you guys, the auditors, to do this? Yeah, you are, but you're also paying us for the extra audit time it's gonna take us to analyze your code after we make you fix it. So just prepare stuff like this in advance and save some time. For the automated workflow, some useful tools to keep in mind would be, code coverage. I really recommend Hardhat as a dev environment. It has really good tool support. Foundry has been growing as well, but avoid Truffle. Every single project with Truffle is a nightmare to support. You want to have continuous deployment as much as is possible in blockchain. You want to have linters, tests, fuzz testing if you're feeling frisky. It's a bit of a job to set up, but it's very useful. And Mythics is an easy integration that is going to provide like a little bit of security. And on the topic of security, let's get, I hope you're all ready to get into the practical side of this. So now that we have some theory and general working approaches set up, we're going to be looking at some common blockchain exploits that you should learn and be educated on before you're developing a Web3 project. Because some of these are quite unique and most developers wouldn't expect them. Because they're, I mean, you get to these when you're working with parallel processing and fancy languages, not when you're writing simple code, which is what blockchain code tends to be. So that's why. So for a start, we have the most famous one, the child star reentrancy. It's devastating. It's been associated with a few major hacks, and it's pretty much it's a mutex situation. It's two things interacting with the same memory before everything is done. And the way it works is you have a function, for example, a withdrawal function, and it's changing some balances. But it's changing those balances after transferring the funds to whoever is calling it. But when you're transferring these funds, there's a cool feature called the fallback function, which you can invoke and which will allow you to call back to the contract, back to that withdraw function, and catch it once again and get extra funds and do that until it's drained. And the way we fix this primarily is changing the contract state before making an external call. And that is called a check effect interaction pattern, and it's a really important pattern to remember in Solidity. And the other option would be using mutexes, but these are a bit of a patch because they cannot be as secure as they make you feel they are. So using mutexes, the most common one would be the non-reentrant modifier from reentrancy guard by Open Zeppelin. But the thing with these is that these are only on the single contract, and if you have a complex contract system, it's not going to prevent cross-contract reentrancy, which is what's been getting more and more projects lately. We've caught a few examples of that, and it's sort of tricky, and there's no good libraries for that. So some famous incidents would be the Fei protocol hack, Uniswap, Cream Finance, dForce, OmniNFT. These are all very different protocols, but the hacks pretty much all work the same. So I'm going to be pasting a link, maybe. I'm not sure. In any case, you can follow this link here. Or maybe can I present my screen? I'm not sure. But in short, on this link, you can save it, or maybe Kate can help me put it in the chat. You can see two examples of implementations. So you have three contracts: deposit funds, attack, and deposit funds fixed. And so deposit funds, it may look okay at first, but notice on line 14, balances message senders equals 0. We're updating the balance here. But this update happens after we're doing this on line 11 message sender call, sending the money, sending the funds. And that is a violation of the check effect interaction pattern. And an attacker contract, you can see the contract attack below, has a fallback, which checks, which simply reacts to this sending of money and calls back to the contract to withdraw again, because the balance hasn't been updated, and you can keep withdrawing on and on until the contract is empty. And to fix this, you simply move the balance check, as you can see in deposit fixed on line 49. You simply move it before the value transfer. This is like a simple example, but following the same pattern is gonna get you most of the way there, and we're gonna catch the more complex cases. So it's a simple fix. It can be a bit more complicated when you're working on big systems, but for for most simple stuff that you're likely to be building, it's going to be plenty. So feel free. I'll probably be sharing this presentation as well, so you can take a look at all the materials later if needed, and you can take a look at these examples for learning. The next one, we can move to slide 17, denial of service. So this one works a bit differently than you would expect. If everyone's messed up with, what are the kids' tools? LIOC, low orbit, LOIC, low orbit ion cannon, which is like a packet spam tool, and other silly tools, that ship with Kali Linux for DOSing stuff or DDoSing. It's a vulnerability that usually happens when you spam a server. But on blockchain, it's actually a lot more elegant to do a denial of service because of contract state and reverts. So the way it works on blockchain is there's three ways actually, but in general, you're causing a revert via getting the contract into an invalid state that it cannot recover from. And by recover from, it's usually very simple states. So where your logic in development made it possible. There's three ways to implement it. For one, you can have a similar fallback situation to the reentrancy attack, where you have a transfer and then the fallback reverts simply. Instead of calling the function again, it simply reverts and it blocks any transfers on that function or something like that. The standard example for this would be like an auction where you're transferring using a push pattern instead of a pull pattern, which I will explain later. The second option would be an error in the smart contract logic, which would be just like a locked state. You had required somewhere that really shouldn't be triggered, but you made it too broad or something, and now it's triggered, and it was your mistake in setting up the contract logic. And that's usually because you didn't map out, the states well enough. And last one would be due to array size limits or gas limits. So you have, for example, 1,000 users, and you want to distribute funds to all of them, and they all send you some money, and then you're like, okay, let's send this to all the users, but you just have a function that gets all the users and tries to send to all of them, and you simply cannot do that because of gas limits on blockchain. So that would be the third option. And the way you fix this is you change from your token transfers from a push to a pull pattern. That would mean that you don't send money to people, you make it available for them to take. Why? Because then you're never blocked by someone by trying to send funds to someone. They can only block their own funds, pretty much. You can also block calls to non-verified contracts, which is a bit tricky in some cases, but it's a valid option, making a closed system. You will be imposing limits on volume of data. For example, you may have an admins array, and there's not going to be more than 10 admins, so it's just limited here. So in case of an issue, there's no problems actually running this. And of course, you want to cover everything with tests, including marginal cases with 50, 100 users. You're not going to be testing with that many, but situations like that, or general edge cases, you need them. And for the code example for this, we're going to be taking a quick look again. So this DOS example, we have two cases. We have token distribution, and we have auction. Auction is the school example. Can you just help me share this? Okay, in short, similar to the first to the reentrancy case, we have the contract auction at line 5, and this smart contract has a function bid. Line 5, please. And in this bid function, we have like the function. It checks if your bid is higher than the previous highest bid. That's line up, please. You can see the line numbers to the left. So you have on line 10, require message value is bigger than highest bid. That checks if you are bidding more than the previous highest bidder. And then it tries to send the funds that they originally bid to the last highest bidder. And then it, everything else is as you'd expect to be. You're the new highest bidder and your highest bid is the new highest value. But the thing is, we're trying to send the funds to this highest bidder. And the unsafe example 2 is the same thing, but with transfer, which works just slightly differently, but it's all the same. And this highest bidder can be an attacker, you can see below, and it simply has a fallback. It simply has a fallback function, receive fallback function, which always reverts. So it's gonna always revert. That's it. And it's like a simple thing. And the solution to this, if you scroll down to attack and auction fixed. So in attack, you can see the receive fallback always reverts, and then you can see auction fixed. So you again have the bid function, but this time you have failed transfers, where it tries to send, and if it didn't manage to send, it adds it to failed transfers. And there's a new withdraw function, which is the pull pattern, where you're actually getting the funds back. And we're actually being nice. We're still sending to everyone who's not trying to DOS us. It's just that for those that do try, that do fail the transfer, we just add it to the pool where they can withdraw it. And the second one, if you scroll down to distribute tokens, is what I mentioned. So you have too many investors or something, and you're trying to distribute something to them. There's just too many. You misjudge something, and you can no longer get enough gas to actually pay this transaction. And those are like the two main ways you may get a denial of service. And both of these would, of course, be flagged during an audit. So we can move back to the slides. And we're going to have some more code examples after. And just one more, actually. So we have authorization via transaction origin. This one is also something that doesn't show up in normal code. It's a global variable, and it's the signer of the transaction. So if I interact with a smart contract, for example Uniswap, and Uniswap forwards my transaction, like my transaction touches Uniswap router, and then from Uniswap router it touches several swap contracts for different currency pairs. For the whole time, the transaction origin is going to be me, but the message sender, another global variable, is going to be whatever the last contract in the chain was. And the problem with authorization with a transaction origin is that you're literally checking that the originator was so and so, and this can be hijacked, because if I touch a Uniswap router and it routes to a malicious router, that malicious one can take my transaction origin and use that signature anywhere where it's been implemented maliciously to do something. It doesn't matter. And the simple solution for this is just don't use it. Use message sender instead. Yeah, for this, of course, you will need to again create an attack contract with the callback function, and somehow get the victim to call the function on your contract, which is the tricky part. You need to actually fish someone or something, so it's a bit harder to execute, but it's still a common issue. And it's pretty much a form of a phishing attack. So again, the solution: don't use streaks origin, use message sender. And if you for some reason really intend on using transaction origin for authorization, do not have callbacks or anything, and don't make transfers to non-verified contracts as well. But in general, just avoid transaction origin. It's only used in like a few specific cases, like end user account checks and similar, not for general authorization. It's just not meant for that. And if we take a look at this code sample, you can see like a simple transaction user wallet, which authorizes using transaction origin for the transfer. And you can see the attacker simply forwards some transaction that was received to this and transfers as if they were the user. It's trivial, and nobody should be vulnerable to this in 2023, in short. So this is the very standard case. As you can see on line 16, required transaction origin equals owner. So you're checking that it's owner. And you can see on line 32, receive, that's a fallback function format, which calls the transfer to as whoever called this. So that's it. Tricky stuff. Okay, and back for the final item, and no more. Oh, actually, there's going to be one more. Sorry. We have delegate call. This one, you're not going to encounter this in your first, half a year of coding in Solidity, because it's a more particular feature, usually used for flash loans or multi-sigs. If you're coding like a bit more of a complex use case where you can't really use all the nice libraries. But in short, call and delegate call enable you to develop modular code. And one is launched in the context of an external contract, while delegate call is the same as a standard message, but subject to execution. These are done in proxies, etc. And in short, just use the code as a library and approve calls only to trust addresses. You're going to be seeing this in proxies, transparent proxies, flash loans, and similar stuff. Loans in general, probably. And these are not something you're really going to be facing. This is all code audited by really big companies a lot. You're going to be using an Open Zeppelin library. And you can sort of mess around with it, but I'm not going to be going into detail on this one. So I'm going to leave the code example. Actually, we're not going to be taking a look at this one now, because it's a bit advanced. So one more attack that we have, I mentioned flash loans. And flash loans, they're a special thing on blockchain. So, okay, if I want to borrow you $500, I'm going to need something in return, right? A guarantee. I need to know your name, address, whatever, at least. But on blockchain, there's a really cool thing. You can borrow and return within the same transaction. Say you see an arbitrage opportunity where you can earn some funds if you can just exchange these two currencies and balance these two pools on Uniswap or something. And you see it's a big opportunity. You could do it with $1 million, but you don't really have $1 million. You have a few $1,000 or maybe 10,000. And there's this glorious thing called flash loans, where at the beginning, it gives you some money at the beginning of the transaction. And at the end of the transaction, you're returning all the money. So it's zero risk for the lender, because they are 100% certain you will not default on the loan because it's logically pure. And it allows for a manipulation of a token price and balances. So, for example, if you have a little token and you have your own little Uniswap pool, and that's the only pool you have, somebody can take out the flash loan and make like a little sandwich attack if they see where they borrowed the token and then sell it again and get like a slippage difference for earnings. So these are things you want to keep in mind in general when you're running your own tokens. And what you want to do in that case is get an oracle and a transaction delay. So a transaction delay is going to make most of these attacks impossible because the flash loan is going to be looking at the price in the current transaction normally. But if you add a delay, it's going to be looking at an old price, 15, 20, 30 seconds ago. Doesn't matter. The key is that when they're modifying the price, they cannot actually use the modified price. So they lose the profit opportunity. So that's one solution. Another solution, if your token is a bit bigger and maybe listed on multiple exchanges, get an oracle, get something like Chainlink, and make sure you're working with a proper price like that instead of relying on your own very, very local price. And of course, never take for granted the balances of any system, because a flash loan can massively influence balances. Say you have a smart contract, which is like, okay, if we get $1 million investment here, something is going to happen. Somebody takes a flash loan and gives you that investment, but only temporarily because there was some way to withdraw it. But they trigger whatever the condition was. So do not really rely on balances if you are not in complete control of them. So those would be some very, very important things to know in blockchain. There's a lot to study here. You could spend months just learning about these few exploits, and delegate call will probably eat up like 4 weeks of your time. But the next thing you want to know about in blockchain development, blockchain security, would be what would be like a more long-term protection. So at this point, you are like a sort of experienced developer. You know how to code well in Solidity and wherever, and you know how to write secure code. And what you need now is to also align yourself with the business perspective a bit, which can be hard as a developer. And for that, we get to external review, which is usually a mix of security and marketing. Here we have audits, bug bounty programs, and penetration testing. So audits detect vulnerabilities and confirm reliability to community. These are very useful because they're a fairly cheap check that's going to give you a lot of stuff to fix. It's going to give you weeks of work just making your code better. And it's going to save you some money on the next step, which would be a bug bounty. Bug bounty is something you must have if you're a project of any proper size, because it's pretty much like a statement that if you hack me, I will pay you. So people will not try to steal from you. They will rather go for the easy and legal money, and just tell you about an exploit. And in that case, you pay for verified bugs. The reason why I mentioned audits save you money is because an audit is going to cost 20, 30K or something, and it's going to find 5 bugs or 10 bugs or 50 bugs if you're really bad, But a bug bounty is going to cost you 10, 20K per bug. So it's a very good way to save some money on the future bug bounty. And finally, we have penetration tests, which are a traditional security thing where you're going to check the whole system outside the smart contracts. So why do you need an audit? Well, you as a developer, you see your own project and maybe previous projects you worked on. But we have and you're focused more on development than security, while auditors look at hundreds of projects and are focused purely on security. So on the one hand, you have the irreversible nature of smart contracts. Mistakes are very expensive. And on the other side, you have the fact that you get an external view, a new pair of eyes on this, and we will detect things you may have missed, and will in general confirm reliability to the community. Like, we're not only protecting you, the project owners, we are protecting the community. If you're really scammy, if you have a rug pull method somewhere in your contracts, we're gonna tell you and the community about it. We're gonna give you an opportunity to fix it, but it's in our report. We're not publishing that report unless you fix it without it. So that's how an audit works. It can be a bit of a stressful experience, being told that your code doesn't work this way or that way, but it's for the good. So the security audit, it validates your whole system. So we overview your system, all of your requirements. We make sure you wrote them, so better write them the first time around. Analyze your security, use all the fancy automated tools. Many of them you can use yourself because they're open source, but some are more private. And we analyze it line by line with several auditors. And that's like the way it should be done, because fresh eyes plus good attention. And in this final step, the way you prepare is, well, if you followed all of our guidelines, it's going to be minimal. You just designate a person, that's it, because you already have unit tests and good coverage and technical overview and functional requirements and a good idea of what your project is. And we're just, yeah, we see that you may have missed this very obscure bug here that leads to some funds losses, or hey, here are some gas optimizations, but in general it's going to be a fairly smooth process. And some projects may just go through one or two reviews to a perfect score, while other projects, they do not do that. They are very, very insistent that their baby is perfect. So we get horrible code, and then we tell them, and then they're unhappy with their score. So we tell them, you have to fix this and that. And it takes like 5 months and 17 reviews to get an actual good score. So yes, as I said, preparation is the foundation of an effective process. And yeah, if you don't believe me, just check our reports. You can see some seriously long report timelines. I mean, clients hanging around for months because they came up with bad requirements, and other clients getting through the process in like days, weeks. The second thing we have is penetration testing. So your smart contracts may be secure, but the people behind them may not be. And you want to make sure that you don't have any key leaks, you don't have any hot wallets somewhere in your off-chain code that control everything actually. And yeah, there may be a gazillion hacks. Your DNS may be vulnerable, so you may have a perfectly bulletproof sale contract for your token or something, but someone's just gonna abuse your website and make it sell a completely different token. Or your Discord. It's very common actually for people to get messed up in Discord. So it's going to be like a standard security overview, and it's going to find any weak spots. And finally, bug bounties. Bug bounties are like a really solid wall, because you're rewarding white hat hackers. And between us, the difference between a white hat hacker and a black hat hacker is whether they think they can get away with it. So you're going to pay the same guys that would normally hack you to just tell you about it. And it's going to be dozens or even hundreds of hackers looking for exploits in your system. And they will often find stuff that was not found in the audit, as is expected, because the audit had just 2 or 3 people checking it, while this was hundreds. And it's a crowdsourced, ongoing, cost-effective effort where you get a lot of knowledge from different areas in your defense. But still, and that would be the end result of a complex approach. So security, stability, data integrity, confidence, community trust, and investors trust. You know exactly what you built through functional and technical requirements. You implement test-driven development to validate everything. You have a good, clean, automated workflow with analysis tools being run regularly, a smart contract setup, security mindset, and you had some external reviews, and your project should not get hacked, pretty much. So that was the end of the presentation. If you are interested in any advice, or if you have any questions after this, feel free to add me on LinkedIn. And yeah, it was a pleasure talking to you guys. If you have any questions, please drop them in the comments now. I will gladly answer even off-topic questions related to blockchain development. There's always, good stories from the pit. I'll give you guys another minute or two, and if there's no questions, I think we can end it pretty much here. Yeah, I think this would be it. So you can end it here. Okay.
Hello, everyone. Welcome back to our today's workshop. So thank you for, I'm not sure if you listened to the previous workshop with Hacken, but we had a very amazing sharing from Noe, the lead SE auditor of Hacken, who introduced to us the test-driven smart contract development on Hacken. And after the break, we will soon have Team Zhang from ChainIDE, the CTO of ChainIDE. So ChainIDE is one of the community partner of the BNB Chain Zero2Hero Hackathon, and they have a very strong developer community all over the world. And today their topic is AI-driven Web3 application development. So, hi team.
Hi, Kate. So yeah, I'm very pleased to be here to give this presentation. So basically, share some of our practices in like AI-driven and full-stack Web3 application development in the environment of ChainIDE. Yeah. So I just listened to the previous presentation from Noah. So it was very brilliant, and it is more kind of like a knowledge-based, right, presentation. So it shares a lot of kind of experiences and knowledges to all the builders here. So my presentation here will be a little bit practical. So I will probably go through a process of how to use like AI and AIGC technologies and tooling to build a full stack Web3 application in the environment of ChainIDE. All right. So, so first section will be the AIGC for development. So I will go through the current status or state of art AIGC tooling. So there are a bunch of like AIGC tools that can be used for Web3 development, right? So if we don't like limit the scope for Web3 development, that would be like much more. But for Web3 development, I think these are three most useful categories of AIGC tooling. The first category is code helpers. So which means that it can help us to write code, especially in Web3 development. We have different type of code like smart contract code, front-end code, back-end code, and even if you are doing any kind of low-level blockchain development, there will be like blockchain low-level code, right? And the second category will be art generation. So especially in Web3 development and the the NFT related projects, the art generation is very important. So usually in the past, we will like a lot of projects will have we will hire the artists to have to contribute to their art, because usually for a very well designed NFT project, that will be like thousands of pictures and thousands of like 3D models needed for a single project. So art generation will be very useful in this area. And third one will be the automated workflow. So basically, if we because the difference between the Web3 development and the regular Web2 development will be you have a very different pipeline for smart contract, right? So besides the front end and back end will be similar to Web2 kind of like DevOps. So smart contract is very specially designed, pipeline to run. So in this case, if we can have any kind of automated tools, automatic AI kind of AI or agent, that will be very helpful in to help us to accelerate the development. All right. So for code helpers, we usually have this. So these are kind of the top competitors like in this area. So we have the GitHub's like code copilot, right? So I think that's also powered by the OpenAI's like LLM, so large language model. And also we have the cursor, so that's also powered by the large language model. And Tabnai is kind of a very interesting example, because it was originally a code kind of like it was like in this area for quite a long time, and originally it wasn't kind of powered by the large language model, but recently I think they are kind of like they're trying to adopt this technologies in their existing kind of like database, right? And the last one to mention is always the OpenAI's ChatGPT. It's kind of general purposes chatbot, but a lot of people use this for kind of like for writing code, and it has a very good, effect in writing kind of, especially in writing simple code or writing a starter template. So later in today's kind of demonstration, I will also use like ChatGPT. So for art generation, so there are a bunch of like closed source and open sources toolings available there. So for example, for closed source tooling, we have Midjourney, right? So Midjourney is currently, I think, by far the most popular one, and we also use it to generate a lot of kind of like hero images for our website. So today we will use the Midjourney, and of course there will be the DALL-E 2 from OpenAI, and also the Stable Diffusion. Yeah. And the workflow automation is the area I think that will be very, will be developed a lot in the future, because it's kind of a orchestrator of all the tools I mentioned in previous two like slides. So it can help to automate all these tools and make the agent to help you solve the actual problem, instead of like you define the problem, you divide the problem into sub problems, and you do them one by one, maybe like interact with like several AIs, right? So this will help you to coordinate or orchestrate the AI workflows. For example, we have the AutoGPT, the Agent GPT. Agent GPT is kind of a web version of like AutoGPT, and we also have the Camel. So Camel is a kind of actor-based like AI. So it try to kind of it's like you are raising a real person, and let that person to do jobs for you. All right. So these are I think we already like covered a bunch of like toolings that can be used in in Web3 app development, but how to do that? And so right now I want to give you an overview of one of our past practices of incorporate all these like AIGC toolings in ChainIDE to build a full stack like decentralized application on BNB chain. So the application isn't it isn't novel, isn't new. It's just a full stack NFT dApp. So usually for a NFT dApp, right? So we all think about, okay, we have 3 different components. The first one will be the smart contract, right? So that's usually like an NFT on the EVM compatible blockchains. That will follow the ERC 721 standard. Okay, and the second one will be the backend. So I think this is kind of like a controversial that a lot of people want to use. The immutable storage or decentralized storage, such as the IPFS, to store these images. But recently there are more and more like technologies and like advanced technology advancement in NFT area, especially like the dynamic NFT. So we would consider maybe we have a dedicated backend, right, that has that has dynamic logic to handle the immutable data, or maybe to enrich the immutable data will be more useful. So in today's demo, I will build a NFT metadata storage in JavaScript as the backend. And the third part will be the front end. So usually for a for that, front end is very crucial because it includes all these user interfaces and the interactions that the application offer to user. So in NFT scenario, so that will be a NFT mint page. All right. So this is the kind of the structure of a full stack NFT dev. Okay. So the first step of starting this development would be you have to have a kind of wallet. So that's installing MetaMask. So yeah, so here we have the links there. So if you have the slides, right, you can take it home and follow each steps in the slides to build that. And the second step that's very important is to visit ChainIDE, because ChainIDE will like officially support multiple blockchains, including EVM and non-EVM blockchain. But in today's demo, so the most important part is the BNB blockchain, right? And the BNB blockchain, BNB chain is the most one of the most supported blockchain in ChainIDE, and we have tons of like templates available there, templates and plugins available there. So if you want to follow this this tutorial, probably you can just click on try now, and then you have the unlimited like right now it's unlimited kind of CPU and memories there. And yeah, and then choose a login method to log into ChainIDE. The third step is to start with importing a GitHub repository, or you can just start with a like template there using the template wizard. So in our case, I think in our practice, we start with a blank template because we want to start from scratch to see whether we can use the AIGC tooling to create a full stack dev. All right. So the first AIGC tool we're going to use is the ChatGPT, and that is we just use the 3.5 version. So we didn't use like ChatGPT 4 version is mainly because there's a kind of rate limit there. So we want to try as much as possible to see like what's the possibility we can have to use the ChatGPT. So yeah, the 3.5 is recommended, but you can also use like ChatGPT version 4 to see the difference. All right. So here is the first prompt we actually send to ChatGPT is we want ChatGPT to create a backend code of that NFT metadata storage. So the prompt that we give is, this is just a random kind of prompt written by one of our engineers. So she's not a prompt engineer, so she's just a normal developer. So what she wrote is, give me an example of NFT metadata service using Express, right? So it's she actually asked for the framework she want to use. So it's Express. And for querying, there's a typo, for querying two constant NFTs as an array representing planets. So it also kind of tell ChatGPT, okay, so what is this NFT about? It's about planet. Okay, so hopefully ChatGPT will create the description and metadata for planets, so which has visualized description. So I don't really understand what does visualize here mean, but yeah, it's just add some additional information to ChatGPT. Okay, so here's one thing we discover is that if there are no query, so because you know that the AI is kind of probabilistic model, right? So like even you have the same input, it cannot guarantee you get the same output every time. So if you have no query like planet / ID, so that chunk of code there, so probably you can tell the AI, okay, can you add a can add this API to the code. All right, so this is how we get the code chunk. Yeah, so this is the code. So you can see in the original code, we don't have that API, but later on we ask for it. Okay, and there's another file we still need. So that is the actual metadata, right? So we have this 10 planets NFT metadata also generated by ChatGPT. Unfortunately, in our original prompt, it wasn't there, so we created a separate prompt to let them generate. But this is so you can see this array is that contains the metadata is also generated by ChatGPT. So what we will do is we will create a folder called backend in ChainIDE, and then we copy the code and the generated metadata from ChatGPT UI to the ChainIDE's UI. And then what we will do in next step, we will open the sandbox, which is a feature offered by ChainIDE to let users to create a virtual machine that has pre-installed software running in the backend for users to test their code in the browser, just like they're testing in their development desktop. So we will open the sandbox. So here, what we created is a Ubuntu runtime that contains all these BNB chain libraries, such as I think we have the npm installed, we have hardhat, and with BNB chain config installed there. And then what we will do is we will have, even though we have the code, we still need to do some additional step to initialize this code. So what we will do is we will go to the directory of backend, and then we initialize this npm project for our backend. And then we add the framework Express, right? Because we explicitly asked for Express to the ChatGPT. And then we'll also need to, that's all these dependency done. So the next step is we will just run the metadata.js. All right, so after running all these commands, what you can see is the server started on port 3000, right? And then what we will do is we will create a port forwarding to expose this port through ChainIDE's port gateway, so that we can access that service from the public internet using this port manager UI. Yeah, and I think we didn't have. I didn't add the screen after this step. So the server is running, and we can access the metadata of all these planets the metadata generated by ChatGPT. Okay, so here comes to the second AIGC tooling, which is called the Midjourney. So the reason we use Midjourney is, and ChatGPT is mostly their availability is much better than these open source tooling that you have to set up and run it yourself. So you can just directly go to Discord. Yeah, before that you need to have a paid membership, but then you can go to Discord to write the prompt or aka description of the image you want to have, right? And then Midjourney will just generate the art for you. So what we did is we just copy the description generated by ChatGPT to describe all these planets, and then we pasted the description to Midjourney, and it would just generate a whole bunch of different images for us. For this one, we didn't add any kind of parameters to tune the output because it's just for demo. But in practically, you can have a lot of parameters to generate different styles of the images, such as like anime style, or like a kind of like a realistic style. Yeah. So here are the planets images we generated, right? So then what we did is we paste the URL of these images into the metadata file. So this is a manual step, right? Okay, so after updating the metadata.js, then our backend is all good. So we have a running server that is serving the JSON metadata and also the URL of the generated images. All right, so the second part will be the smart contract. So the prompt we gave the ChatGPT is also very straightforward. We didn't have any specific requirements from the beginning. So what we did is, we asked for an example of simple NFT contract written in Solidity that overrides. So this is the only requirements we added in the beginning. Overrides the base URL function and rename it with the private base URL function, right? Because this is what we discovered, that even though using ChatGPT, it will give you some kind of like a response that looks reasonable, but usually there are some pitfalls. So we need to like slightly modify our prompt to form a conversation with ChatGPT, and then in the end, so it will give us a kind of satisfactory answer. And we found there are some like possibilities or branches there. So if so luckily we get this in the first time we get a kind of runnable complete smart contract. But after several tries, we found sometimes it will miss a mint function. Then you need to tell ChatGPT, okay, add mint function. Sometimes there will be some like missing parameters, right? Like token URL. So you so there are some additional parameters. So you probably want them to want ChatGPT to remove these. Yeah. All right. So this is a conversation, right? So we actually asked ChatGPT to create a smart contract and then add a mint function, and they will just create this code for us. Yeah, and we just have like 3 sentences sent to ChatGPT, and then a runnable smart contract there. Okay, so what we did, this is quite simple. We copy it to ChainIDE, right? And then we use the ChainIDE has its automatic compiling function that will automatically compile that smart contract for you, and then we moved it to the contracts folder. So right now we, as you can see, we have 2 folders. The backend folder contains all these the service, the metadata backend service, and the contract folder contains the smart contract. I think there's only last thing that is need to be done is the front end. All right. So after compile, there's no error, then we're good, and then we do a deployment. So in the deployment step, what we did is we get the previous running backend service, and then we get the URL of that endpoint, copy it to the deployment, copy it to the deployment tab, and then we deployed with that as the base URL. We made a mistake at the beginning because we forgot to add the planet in the past, but we fixed that in the second try. And after that, please verify in your smart contract in ChainIDE. You can just directly invoke the read function base URL and then copy the return value and open it in the browser. If you can see, I think there's a hello there, so which means that you're hitting a right endpoint. All right. And the last thing will be, after deploying, we have the smart contract ABI and the smart contract address, right? So then what we did is we use the last prompt. Give me an example of React app that connects to the MetaMask and allow users to mint NFTs from NFT contract we create earlier. So you can see this is a conversation, and the ChatGPT actually memorized what we did in earlier stage, and it generated a smart contract. Sorry, it generated a React app, and luckily this React app is very good, and I won't say it's bug free. We still need to like plug in these values, and also there are some manual steps to add the dependencies, right? So because it only gives us code, it doesn't give us all these steps to initiate or to run the code, but it's much smoother than like previous two steps. All right, so what we did is we used the npx, so it's the execution mode of the npm, and we create a React app using the create React app command, and that will create a folder called frontend. And then we install all these all the needed packages. So here is the outcome of the project. We have 3 different packages: backend, contract, and the front end. And in front end, we have all these source code, the package.json, and all these things need to run a React front end app, right? And then we copy the generated code to the app.js. And the last thing, we need to add the dependencies. So there's only one dependency we need to add, is the ethers. So I think this version is just tried by is figured out by our engineer, because I think if you use the latest version, there will be some bug there. Yeah. All right. So after that, we after running the npm start, the dev server of the front end is up, and then we need to do the same thing, port forwarding, and to make sure it is accessible from the public internet. And then we open the link. All right. So after the front end is being deployed, we can use our account and use our account in MetaMask to mint a NFT, and the minted NFT will have the metadata we just generated, and also the image that is generated by Midjourney. So this is the verification results on OpenSea. All right. So after we did all this, yeah, we need to make a at least make a log, or to store all these like records we actually created. So we use the upload to GitHub functionality provided by ChainIDE to directly upload the repository, the project to a repository. So in the bottom of this slide, there it is the URL. You can just directly go there and download the project to see if you can replicate or run it locally. All right, so this is a full video. So yeah, so I will just go through the it is exactly what I just talked about. So the process I already talked about, but it's still better to take a look at the video to see like what happened step by step. All right, so first of all, we go to ChatGPT. Okay. And then we ask ChatGPT, okay, give me an example of the backend, right? And it just keep generating this code, right? Yeah, and it adds some explanation to tell me, okay, so what to do with this code. No, it's very nice, right? And then after getting this code, right, so we don't actually know if this code is runnable, then we go to ChainIDE, create a new project with a empty, with a blank template. All right. I'll create a backend folder, right, and we name the file just generated as metadata.js, and then we copy the code into this file. All right, so it already generated the NFT metadata for 2 NFTs, so Earth and Mars. So in our previous screenshot, what we saw is just the Mars NFT, right? So we already generated this Midjourney. Yeah, I think this is the description we use to generate in Midjourney. Let's see what will happen. It takes some time. Yep. So these are the picture generated by Midjourney. And what we did is we choose one. I think the one in the bottom. So yeah, we got the actual image, and we open in the browser. We copy the link of this image, and then we paste it into the metadata store. Yeah, we did this the same thing for the Earth. All right. And then the last step is we run a sandbox, which is a virtual environment for running and testing our code. All right. So here it is. And yeah, here we already started this service, right? And then we added the port forwarding to make sure this is accessible from the public internet. Yeah, and then we can already see there's a response of the Express server. Yeah, and then what we did is we tried to access the metadata of NFT1, and then we got the actual metadata needed. And then we click on the image, and it shows the correct image generated by Midjourney. All right. So here we successfully run a backend service with the help of Midjourney and ChatGPT, and then here comes the smart contract. Yeah, it generates a smart contract for us. So we keep talking to ChatGPT. Okay, so we want to add some API, remove some parameters. Yeah, I'll just skip this one. And yeah, in the end, we got a runnable smart contract. Oh, it's still like we're still talking to ChatGPT. All right. So what we did is we finally got the NFT smart contract we want. Then we pasted it into ChainIDE and successfully compiled it, right? Because it will take some time to download all these OpenZipLink libraries. Our compiler got the ABI, and we deployed it with these parameters. So what are the parameters? So we have the smart contract name is planet, right? Planet symbol string, and symbol is empty. Sorry, we haven't given it. Symbol is PT, and the base URL is what we just had in the backend service. So we just put it here. Then we click deploy. Yeah. So after deployment, so we can see all these interactable APIs will be shown in the interact pane, and then we can start mint a NFT. Okay, so after the minting, we can see this. URL of this transaction, and we can go to the BSC scan to see what just happened in this transaction. Oh, so what we did is just we directly get the token URL by calling the token URL API, and then we copied the returned value. So this is already connected. The token is already minted and showed correct API. Showed the correct metadata. All right, so last one will be generating a front end for minting an NFT. Okay, so what we did is we installed the React and yeah, it takes some time to install these dependencies. All right. So, if I remember correctly, for the front end, we didn't do much change. So just some minor change in the rendering part. And then what we're going to do is add the dependency, which is the ethers like version 5.7.2. Yeah, it takes some time to install dependencies. I'll just skip this part. Okay, cool. This the dependency is installed. Then we run the npm start. So it started the development server at the 3001, the port 3001, and we add a port forwarding, so we can directly open the front-end app. So it's just a simple mint UI there, but you can actually invoke the API here. So I think there are some debugging going on. Yeah, we got the token ID inputted here. Yeah, so the second token is minted from the through the front end, and we have two tokens that are already being synced on OpenSea. And then the last step is we created a public GitHub repository and upload it to there. All right. Yeah, creating a repository. And it will show before creating it, it will show which files you want to upload. So yeah, so you can just check all these files here. All right, so the repository is created successfully. That's the end of our journey of building a full stack application in ChainIDE. All right, so after this, after kind of like try all these AI GC tooling and build a full stack dApp. So there are a few things we retrospected, and then we found that there are several lessons learned. So the first thing is it's like talking to a like LLM is kind of like it's interesting, but if the LLM isn't kind of pre-trained or like fine-tuned, then probably you need to give it a lot of instructions in order to get the correct answer. But if there are kind of like pre-trained or fine-tuned models there, so for example, if we have a kind of raw model that is then we pre-train or fine-tune specifically for smart contract, then that may be more accurate than what we just got in today's like ChatGPT like generated file. Because in ChatGPT we actually spend, I think, maybe like 5 minutes to talk to it to just get a very simple NFT smart contract. All right. And the second one would be the prompt engineering. So so after several trying, we found that more accurate prompt will lead to more specific prompt will lead to more accurate answer. So especially in the React one, so we actually told the ChatGPT what we really want, and then the output code is very accurate, and it's directly runnable after pasting it to the ChainIDE. And what we did is just a minor change in the HTML and the rendering part. The third one is even though the AIGC tooling offer a lot of help, but they still need some glue there, especially for NFT and for NFT smart contract backend, front end, right? So it's still very hard for a starter or a new or a kind of newbie of Web3 development to actually master or like actually create a full stack application that is runnable. So it still needs some like manual efforts, such as I need to add a dependency here, I need to change the input of certain kind of functions. So and also there are different AIGC tooling in this demo. So for example, we have Midjourney, right? So if we have a very good pre-trained or like a automated task orchestrator can just orchestrate these tasks one by one, or that would be very useful for the developers. So after trying this, there are a lot of so we learned a lot, and we also have a plan to have all these like AI helper and also the AI task orchestrator being integrated in ChainIDE in the future. So we already formed a team to develop this part. Yeah, and I think that's also the direction of the AIGC in general, not only for the Web3 development, but also for other tasks. It's like model fine tuning, prompt engineering, and the some like automated glue, automated like orchestrator to play the role of the glues. Perfect. Yeah, that's the whole journey of AIGC related development in ChainIDE and our thoughts and learnings. Thank you very much. And if you have any questions, I'm very glad to answer and share my opinion.
Thank you, team. Thank you, team. It's a very good presentation. And thank you for taking such a long time to present with the Zero2Hero Hackathon hackers. So if you have any questions, feel free to post in the chat box, and we will try to answer them. And you can also join the Discord channel and ask questions there. And I know it's a bit late, especially for Asian area. So I don't know where team you are. You're in Asia, right?
No, I'm in North America, but
North America.
yeah, but I actually like waited quite a long time, so I stayed up late yesterday. So just wait for this. Yeah.
Okay, got it. Thank you. So I'm not sure if you have any questions. We don't see any new questions pop out, and we may need to. Thank you, Osama, and thank you for staying up here for listening to this. So maybe we'll just maybe wait for a few moments, and if not, we will take a break, and we still have a workshop with Google Cloud. And let's see. I didn't see any questions so far. And so for all the hackers here, so we for Zero2Hero Hackathon, we have a track named Innovation. Okay, and someone is asking, is there a GitHub link?
Yes. So in the previous slides. Here.
Or you can share the link in the let me share here.
Yeah, so I can probably copy paste it here.
So anyone who's interested actually in AI-driven smart contract, you can choose to join the track, the innovation track, which is I think it's the best track for you to explore the use of AI in the hackathon. I didn't see the link. Maybe I can put it here.
Sir, so it's hard for me to like copy it from the slide, so I will just do it later. Yeah. So thank you very much. Yeah.
Okay. Cool. I'm not sure if you have any more questions.
You're welcome.
So if no more questions, we will stop here and we take a break of 15 minutes, and we will have the last workshop and also the last workshop of all our Zero2Hero workshops from Google Cloud. So thank you, team. Thank you very much. And
thank you very much, Kate. Thank you, everyone.
Thank you for ChainIDE for supporting our hackathon. Yeah. Thank you. Bye-bye.
Thanks. Bye.
So we will take a 15-minute break, and we'll start to explain the ETL pipeline BNB chain by Andrew from the Google Cloud, the principal architect Web3 at Google. And Google Cloud will also explain, because Google Cloud will provide a 5,000 Google Cloud credits dollar. This was 5,000 USD, and how to get these credits for the Zero2Hero Hackathon hackers. So if you're interested in this, you should also listen to this workshop and ask questions. So see you in 50 minutes. So hello everyone, welcome back, and thank you for your listening before for our previous workshops with Hacken and ChainIDE. And now we will have Andrew from Google Cloud, who will introduce to us the ETL pipeline for BNB chain. Hi, Andrew.
Hello, can you hear me?
Yeah, we can hear you clearly. And
Okay.
Okay, you will share your screen here. So maybe you can get started. Yeah, as you wish.
All good? Okay.
Yeah, all good.
You can see my screen. All right. So I'm not sure how it works for question. I guess you guys can ask questions on the chat, if any. So my name is Adrian. I'm principal architect Web3 for Google. I joined recently. Before that, I spent about 4 years at Consensus, working for MetaMask and Infura. I was head of engineering for Consensus. Before that, I was a cybersecurity engineer. Worked in China as CTO and then in the US. I'm French, hence my accent, and hopefully it won't be too annoying, but let's see. Today I'm going to talk about a bounty that we're very excited to propose to you guys. It's the BNB chain ETL, and I'll explain kind of like what it is. I'll share the bounty, and I'll explain a little bit of background of why we're doing it, and so on. Okay, so if you have any questions, please interrupt, or I don't know if you can, but ask questions. All right. So just a bit of recap. I don't know if everyone attended last week's session where we shared a little bit like Google Cloud vision and also effort in Web3. But I'll just recap a little bit and then dive deep into the problem. So the vision for Google Cloud is really to make it easy for anyone to build Web3 products, right? And so, as you know, we're creating a set of products for people to make it easy and using the Google brand, right, as efficiency, reliable, and secure as possible, and make it this kind of building this blockchain infrastructure to make it as easy as possible. And something else as well that's pretty important, and that's focus that we have, is we want to combine effort with the community and push the adoption together. And I think this bounty that we are proposing, today through this event is shows really how much we want to do that and combine effort with the community, and hopefully we can see how we can use this bounty for the different products that we are going to release. Okay, so in terms of Google, I guess everyone knows Google Cloud and how we can help different companies in Web2 companies. But when we talk about Google initiative for Web3 companies, this is kind of like a recap of the offerings and how we can help different Web3 companies, right? So at the top of the slide here, you have the product offering that are going to be released this year. Some of them are here, some of them are going to be released. I'm going to detail a little bit. And then at the bottom, you have like other, offerings that we have as well that are not necessarily products, but that are, I think, important to talk about. So I'll just recap a little bit, and then we'll focus on blockchain data. That is what we want to focus on for the bounty. So the first thing that we're going to release, and that is in private preview right now, is blockchain node engine. So it's BNE. It's not as a service. It's basically a way to have a fully managed blockchain node, right? And we have a roadmap. We're going to start supporting Ethereum first, and then we're going to add new chains, and Binance is part of that as well. We're going to have it, we're going to have RPC as a service as well for that. And that's really the foundation of what Google is going to do in Web3, right? So that's going to be released in about a month. The private preview is going on right now. It's going well. You have a bunch of demos and stuff like that that has been done. Hopefully you can take a look at that. But this is really the foundation of what we want to do, because then when we have this, then we can do the next products or the next steps of the roadmap. And one of these is this blockchain data, right? So when we have the nodes, we can extract the data from the blockchain, and then we can offer it through BigQuery, for example, or we can also offer streaming data directly through PubSubs or message queues and stuff like that, so that people can get started very easily and build on top of any kind of like blockchain. But we'll focus on blockchain data a bit later. Then the third product that we're working on is serverless. It's basically a way to configure webhooks. So when you have the data extracted from the blockchain, and you have these PubSubs that are streaming the data, it's very easy to create what we call cloud functions, or like piece of codes that are going to be executed only when certain conditions are met. And that's really what serverless is about. It's configuring webhooks. So you have certain tools or APIs that are doing kind of like something similar, but here the idea is that you will be able to do it directly from the free data sets from Google Cloud on different set of blockchains that we are going to offer, right? So stay tuned on that. Those are kind of like the products that are coming. And then what, other things that we are doing, and maybe you are aware, is we're running validators for different chains, so for layer 1s and layer 2s soon. So we're running validator nodes on Telos, Sky Mavis, and so on. And that really shows the commitment that Google Cloud has in the space to secure the different chains and participate to the validation of the different chains. And thus making the space more decentralized, because we're running a neutral validator, like separated from the difference from existing validators, so participating in securing the different networks. Web3 advisory. So we have created different teams of professionals coming from cryptos. Myself, for example, with 4 to 5 years of professional experience in crypto. We can help in tokenomics. architecture, smart contracts, and so on. And that's really something that we want to start working on with the different customers that we have. Something else as well is, as you know, Google has much more than just Google Cloud, right? We have Workspace, Google Ads, Play Store, and even though the regulatory framework around crypto is a bit difficult to read sometimes, we can really help you have a point of contact at Google to help you unlock maximum potential, right? So that's really, a summary of what we do for companies specifically to Web3 on top of everything else that hopefully you know about. So if we focus on, blockchain data, if you want to query blockchain data, whatever the chain that you're going to query, whether it is Ethereum, Binance, Polygon, querying means the same thing, right? You need data in a database because querying directly the node is not efficient at all, or it's not even possible. So you will need to do these kind of different steps to be able to query the data. Starting with provision a node. Either you do your own node on Kubernetes, on a VM, on your hardware, or you use a provider like Infura or Alchemy and stuff like that. Then you need to index all the historical data, so going through all of the different blocks that the blockchain have been through, and then putting that in different tables so that you can then query it. And then you need to listen for new blocks to be able to have the new data, and then you need to monitor and maintain this, what we call ETL, which is an extract, transform, and load pipeline, and make sure that it's operational and healthy, so that then once you have done all of this, then you have a healthy SQL or whatever database that you can use to for any use case, right? Every dApp, every service building on top of a blockchain needs this, whether they do it themselves, and that process is pretty complicated, but whether you do it yourself or you have to use a provider such as Moralis and so on, you have to do something like that for any kind of like dApp or that you're building, right? So it might be transparent for some people because you might use a provider, but at the end of the day, if you're going to need to scale, you will need to go through something like that. And the good news is that Google is making it easy to query this data. And so basically what we are doing, and I don't know if you are aware of that, but we index the data for the space, for the community, and we absorb the cost, right? So we run these ETL pipelines for different chains. So I think we are right now running indexes for about 14 different chains. So there is Bitcoin, Ethereum, Bitcoin Cash, Dash, Litecoin, and so on. And we push this data into BigQuery, right? So BigQuery, I'll explain quickly what it is afterwards, in case you don't know. But basically, we push it in this database, and then we leverage an open source ETL pipeline that have the link here. And then when you want to use this data, you can access it, and I will show you how it looks like. You can access it, and you can start using any kind of data that we offer that are highlighted here in red. The caveat is that BNB chain is not in there, right? It's not part of these 14 different chains. And so the goal of this bounty that we are proposing, right, is to create the ETL to have BNB chain available in BigQuery. So just to be clear, right, the goal of the bounty is to create this ETL code that then we, as Google, would run in order then to offer it on BigQuery. So of course you're not going to publish for on BigQuery, and so it's you have to create the code that we are going to run to then offer it on BigQuery, same as what we are doing for Ethereum, Litecoin, and so on. Okay. So just for people who don't know BigQuery and who are not necessarily familiar with Google Cloud, BigQuery is a scalable, fully managed data warehouse that's heavily used by a lot of builders in many industries, especially analytics, right? Because you can have real-time insight into all kind of like data that are aggregated from different sources. And it's very efficient. You can scale up to petabytes of data and very fast. And a lot of people are using it, especially and including in crypto, right? So we, as Google, offer 100+ different kind of data sets, right? That we are offering for free, meaning that we run the ETL pipelines for these different data. And part of those hundreds, we have the crypto data that we talked about. So in order for you to do the bounty and to create this ETL pipeline, you can take a look at what we have done for the different chains that we run. And that's a reference architecture of the ETL pipelines that we run. So it's fairly similar for the different chains that we are supporting. You have the link to the GitHub. And if you look at the GitHub here, you see that you have the Bitcoin ETL, you have the Ethereum ETL. And when you look at the Ethereum ETL, you have all the documentation on how to run it and so on. And because Ethereum is EVM and Binance is EVM as well, it should be fairly similar, and you can leverage the Ethereum ETL code that's in here to create the Binance ETL for this bounty. Right? Okay, so the reference architecture that's here is separated in two different kind of like parts. You have the real-time part that is, the first thing is you need to run nodes, right, on a Google Cloud project. Here we are using Kubernetes. That's making it scalable, and then auto reload and so on, the different kind of nodes. So that makes it easy for us to do. And so we use these kind of like these nodes. We run them in Kubernetes, and then we push and we stream the data in PubSub in real time, and then from there. We kind of like extract, transform, and load the data into BigQuery. And for every operations that are too expensive, right, such as decoding operations, like events and so on, because you know that when you look at the data from the blockchain raw, you don't know, it doesn't have the ABI included. So you might need to have the ABI loaded somewhere else, and then so that then you can see what kind of transaction it is, what kind of data, what kind of operations it's doing, so that then you can extract all of the kind of like enriched data. And these kind of operations that are a bit more expensive, you can do them in a separate flow that is a daily batch, right? And then you can use something like Airflow to be able to do that, and then you reconcile everything inside of BigQuery, right? So this is just a reference architecture. This is just to show a little bit how it could look like. It doesn't mean that that's what you need to do necessarily. And I'll go through the requirements of the bounty and so on, but that's basically a reference architecture. Some data sets that we offer today in BigQuery are only composed of the real-time part here. And so depending on what you want to do and how you want to do it, you might want to add some kind of like daily batches on top of it and so on. So I need to drink a bit. Okay. So let's take a look at what it looks like, so that it's very clear and everyone knows what the kind of like what we are looking for. So if you go on, so here I'm loaded with a project, and if you go on the public data sets that Google Cloud offers, you see here that it offers some data sets around COVID-19, and you can see this data offered for free, and people can just run queries on it. And then you see here a bunch of crypto queries. And I don't know, maybe is it too small? And you see here a bit of a bunch of crypto data sets. So you see here, for example, crypto Ethereum, which is basically public, and anyone can just access it. And you have the link in the deck. We'll be able to share, and you can see the different SQL tables where all of the data coming from the blockchain is streamed in real time to these different tables. And so you have a transactions table, you have traces table, you have blocks table where you have all the information. That's the blocks one is the most easy to understand, right? It's like, okay, it's the raw data coming from the blockchain. You have the timestamp, the block number, the hash, and then you have every information from the block. But then you see that we have other tables like the contracts, the token transfers that need a little bit, that need basically processing to be able to come up with these different tables here. And then when you take a look at when you select one of the tables here, what you can do is click on query here. You can open a query, and then you can select star from this data set here, where so you basically select everything from the transaction or like the blocks one, where the date is today. And what you see here is basically the result. It's an SQL database, so it's very simple for anyone to be able to do its own queries, right? Okay, yeah. You guys are seeing the screen. Okay. Yeah, so it's fairly simple to use, and it unlocks tons of use cases because you have much more flexibility that you would have when you use an API. And if you use an API, then of course, if you want to work through all of the data to count like number of transactions per smart contracts or stuff like that, then it would be very expensive, and maybe no one has done this kind of query before, so you need to go through the whole chain and so on. So that's where using BigQuery is very, very efficient, and then you can, everyone can, without having the need to create a node and so on, can just access the public data sets here, go to the chain they are interested about, and then do the query that they want. All right. So this effort was creating, with there is an open source community that helped us create this different set of ETLs for the different chains, and then Nansen, the analytics company as well, helped us to create some of the ETLs here, the one for Ethereum, for example, that then they use themselves for the different analytics that they are offering, right? Cool. And so what we can do as well is when you go on the Google Cloud Marketplace and you explore kind of like the marketplace, what you can do is you can search for crypto. And you can see here the different public data sets from that are listed in the marketplace here. And so if we click on Ethereum here, you will see the details here showing that this data is basically Google running it. And you have an overview of what it is. And you have some samples query that you can use. So for example, what we can do is what are the 10 most popular Ethereum collectibles. So ERC-721 by number of transactions. And if you click on here, it's going to load the query directly in BigQuery against the Ethereum data set. And so you see the query here, so that it could be a good way to get started and to kind of understand the kind of use cases that you can unlock. So here you basically select like the transaction count, and you have a join between the Ethereum contract and the Ethereum transactions. Then you can count how many, what ERC-721 has the most amount of transactions of all time, right? In the Ethereum on the Ethereum chain, right? And so if we run that, you can see that it's very efficient, it's very fast. You can see the results here, and so you have this result, this smart contract here with by far the most used, like the most, the ERC 721 with the most amount of transaction, right? And so if we go on it can. And you cannot really talk right now, but I would have loved to ask if anyone have a clue of what it would be. This contract is CryptoKitties. So if you know, it's like one of the OG NFT that was created. And yeah, it has the most, the highest transaction count for the ERC 721. It's a game, so everyone is like kind of like breeding their CryptoKitties and so on. So you have a lot of transactions happening for this NFT. And that's a kind of use case that you can unlock, right? So going back to our bounty, I'm going to share the bounty that you should have accessible somewhere, I guess, on the website and such. So the bounty is basically, and hopefully I gave you a little bit of context as to why we want to do that and why it's useful and how to get started. The bounty is to create this ETL pipeline for the Binance Smart Chain, right? For BNB Chain. So this ETL pipeline, the source has to be a BNB Chain node, right? That will run on a Google Cloud project, and the source has to be a Google Cloud BigQuery, right? That's really the fundamentals. And then you can look, there is a lot of material in GitHub with the reference architecture and so on that you can leverage. The requirements for the submission, right, is that the ETL pipeline must meet the different requirements that are here, and then you have some extra points, right? So we'll go through that. The node where the data is coming from, as we said, is a BNB Chain node that has to run on a Google Cloud project, right? So everything you need to kind of like test everything on a Google Cloud project, and the reason is we want you to create some kind of like tutorial so that then you can reproduce. But especially the most important thing is that we want, as Google, to run this project and then offer this, BNB Chain data set as part of the offering that we have, right? So that's really important. The next thing is that it has to extract the data from this node, and then the data needs to be loaded every X minutes into BigQuery, right? X being whatever works, whatever is optimized for you to be able to load the data onto BigQuery. You can use the reference architecture that we shared earlier. The submission needs to include, of course, the GitHub code, right, with the different scripts and the ETL pipeline to be run in order to extract the data and push it in BigQuery, right? As well as a tutorial on how to launch the BSC node, install and run the ETL on the Google Cloud project, and a diagram kind of like explaining, the structure of the schemas, and all of the kind of like differences between the data that you have and how you load it and what it is and so on, right? So if you look here at Ethereum, for example, you have these balances, blocks, you have the token transfers and so on. You can reuse the same structure or you can change it as well, but it's very important to have the GitHub code and the tutorial in order to know how to install it and how to use it, right? Because then the goal, again, right, is to take this submission, and the best one, we're going to publish it, and we're going to run it, and we're going to offer it for free to everyone to use, right? And these data sets here have, a lot of traction, a lot of people using it. So it would be very important for the BNB chain to have also a data set on BigQuery for free, right? Like these public data sets. So yeah, that's basically what the submissions need to include. And then when we're going to evaluate, who's the winner, then we can look at things that are a bit more complex to do, or how to differentiate projects is basically, okay, what about optimization, right? How close to real time are you as possible when looking at the BigQuery data, right? If right now, if we look at BigQuery and we go in the transactions and we look at the latest transaction loaded in BigQuery, you will have a latency, right, compared to your node, right, of course. And so the question is, how much latency will you have? Something else is, of course, handling chain reorgs. So shouldn't have any because it's not proof of work. So you don't have like this kind of like chain reorganization happening, except if you have a bug and so on. But could happen, but not as frequent as a proof of work chain would have, because Ethereum was not long ago. And then something else also is, you see on Ethereum, you have like, for example, this token transfers table. And when you so close everything here. Okay, when you look at the token transfers, you see the token address, the from address, the to address, and basically these are kind of like the ERC20, ERC721 that are listened to from the chain and then put in this table through an indexing process, right? And so that's something as well that could be interesting, is how can you, as you have new blocks being added to the blockchain, how can you parse and decode the events from standard smart contracts using the ABIs and creating custom tables and so on to be able to store like the token transfers and so on, right? So again, this is something that's done for Ethereum, and that could be done as well for the BNB chain, right? So there are a lot of different add-ons, right, that you could that we can think of when we think about these tables that are put on BigQuery that could be interesting and nice to have, right? So those are like kind of extra. Something else as well that could be interesting is in the tutorial or like in the submission to have some kind of like sample queries that you could do in order to unlock use cases, right? So here we talked about the use case where you count the number of transactions for a specific contract. You could look at the volume in ETH or in BNB of a certain collection, whether it's an ERC20, an ERC721, an ERC1155, and so on. Yeah, so that's basically the bounty, right? And the rewards is 5,000 USD worth of Google Cloud credits. And also the winner would have, like we would basically reference the, like who is the author, right? So same as, if Google is the author for creating this a dedicated pipeline, here we would say, okay, this is X or Y person creating this pipeline that Google is running, right, on the marketplace page. Okay. So the last thing that I want to mention as well is that we launched the Google for Web3 Startups program, I think recently, a couple of days ago. So you can take a look at that also if you're interested. And we have, as I explained, we have these different offerings for the Web3 companies, whether it's the products that are coming, whether it's the advisory, and so on. So if you're interested, you can sign up here. You can take a look at that. Follow the links, and I think the presentation will probably be online for you, or you will receive it, I guess. And that's it. Thank you.
Thank you, Andrew. Thank you, Andrew, for the presentation, and thank you, Google for Cloud for supporting the BNB Chain Hackathon. So this is our actually the last one of our workshop series. So after this 2 weeks, and thanks everyone for staying up here too late and yeah, listening to this workshop. And I'm not sure if any questions, because I know it's kind of late. It's already 3 hours. And if you have questions, you can pop the questions in the chat box. We will wait for a few moments. And if not, actually, you can join the, I'm not sure, maybe you're already in the Discord channel. So in the Discord channel, all our partners, including Google Cloud, would be there to answer questions. So just put those questions in the technical questions channel. Also, you can, in the Discord channel, also form groups and form teams with the people and discuss, explore your ideas, your questions with other hackers. And yeah, and also like if you are interested in the Web3 Startup Club program, just scan the QR code here. And so I didn't think any new questions pop out. And if not, I hope you enjoyed these 2-week workshop. And if you're still not clear with the hackathon process, just scan the QR code on the upper side of the screen. Then you will find a Notion page, all the information, including the Cloud's bounty there, and all the dev resources provided by our partners are there. No more questions. So thank you, Andrea. Thank you, Andrea, for joining this workshop.
Thank you very much.
Okay, I will remove you from stream. Okay.
All right.
Comment.
Thank you. Bye-bye.
Okay, thank you. Bye-bye.